So in the last lecture, we seen that one theorem: if p of x is an irreducible polynomial in capital F of x, okay, ring of polynomial of degree n, which is greater than or equal to 1, then there is an extension e of f such that the degree of e over f is equal to n, okay, in which the p of x has a root. Okay, so what is e here? E is nothing but capital F of x divided by v, sorry, capital F of x divided by v, where v is ideal generated by that polynomial p of x. Okay, now look at here. Let f of x be the ring of polynomial over f, and v is the ideal generated by p of x. Okay, so here the p of x is irreducible polynomial. So v is maximal ideal of f of x. Okay, now we define the mapping from f to e, which is equal to f of x upon v. Okay, and we showed that this psi is into homomorphism. Okay, so psi of x, psi of alpha is equal to v of alpha. This is the mapping which is into homomorphism. Okay, we proved that this one psi is 1 1 and psi is homomorphism. Okay, so thus psi is an isomorphism f into e. Okay, now we've taken a subset f star of e. Okay, what is f star? F star be the image of f under the mapping psi. Okay, that is the range state of the psi. Okay, what is psi? Suppose this is f star. Now this is what this one is, the field E. Okay, and now we showed that this f star is isomorphic to f. So this implies f is embedding. Okay, so this f is embedding in E. Okay, now in the step number 2, if we identify, okay, if we identify this capital F and F star, okay, this is an onto homomorphism. Okay, that is if we identify alpha belongs to F with V plus alpha belongs to F star. Okay, इथे काय F आणि F star हे काय दोन्ही आयसोमॉर्फिझम आहे. मग ह्याला 1 to 1 रेस्पॉन्स कोण असणार तिकडे F star मध्ये V plus alpha by that mapping psi. Okay, so then E can be regarded as an extension of capital F. Okay, now we have to claim that. Now we claim that this claim. Wait a minute. सगळे okay, so E can be regarded as an extension of the field F. Okay, now we claim that. What is claim? Look at here. Claim E is the finite extension. E is a finite extension of F. ओके, समजते काय? हा ई आहे तुमचा. ओके, ईचा सबसेट कोण आहे? एफ स्टार. ओके, दॅट इज and this F is isomorphic to what? F star under the mapping psi. Okay, so here E can be an extension of F. म्हणजे F मध्ये जो काही तुमचा एलिमेंट आहे, ओके, त्याला 1 to 1 करस्पॉन्ड त्याच्यामध्ये असेल, F स्टार मध्ये असा असेल V plus alpha. Okay, so here claim that E is a finite extension of field F. Okay, wait a minute. Now for this one, for this E has a finite extension of F. आज जर तुम्हाला दाखवायचं असेल तर काय दाखवावं लागेल? E over F is the vector space. Okay, with dimension, finite dimensional vector
Finite
space. E
dimension.
over F is the finite dimensional vector space. Okay, so for this we shall prove that n elements. Okay, which one n elements? V plus 1, V plus X, V plus X square up to so on. That V plus X raised to n minus 1. Okay, these are the n elements forms a basis of E over F. Okay, now for this one, first we have to prove that these are the n elements are linearly independent, and second one is these are the n elements generates the vector space E over F. Okay, first to prove that these n elements okay of the field E, which is equal to F of X divided by V, are linearly independent. Okay, over the field capital F. So first assume we have the linear combination of that n vectors is equal to 0 element of that field. Okay, linear combination of these n elements a naught into v plus 1 plus a1 into v plus x plus a1 a2 into v plus x square up to so on. Okay, a n minus 1 into v plus x square minus 1 x raised to n minus 1. Okay, which is equal to the zero element of this one. What is the zero element of this one? 1 by okay. V. Okay,
V.
since you reason
V.
V is zero vector. Okay, and where all the A's belongs to that capital F field. Okay, now from the definition of scalar multiplication to the vector, so this implies V plus A1 A0 plus V plus A1x. Okay, is it correct? V plus A x square plus up to so on
Yes, sir.
Yes.
V plus an minus 1 x raised to n minus 1 is equal to V. Okay, now from the definition of two vectors, addition of two vectors in E. Okay, plus a naught plus a1x plus a2x square plus up to so on. Up to so on. This one an minus 1 x raised to n minus 1, which is equal to v. Okay, so this implies if a plus capital H is equal to h, this implies what? A belongs to h. Okay, and from this step we can write this element a naught plus a1x plus a2x square up to so on an minus 1 x raised to n minus 1. This element belongs to V. But what is V? The ideal generated by P of x. No? Yes, ideal generated by P of x.
Yes, sir.
Okay, so this implies a naught plus a1x plus a2x square plus up to so on an minus 1 x raised to n minus 1, which is equal to what is the nature of this element? F of x into P of x. Okay, for some f of x belongs to capital F of x. Okay, look at the definition of V here. Okay, what is V? V is ideal generated by P of x. Okay, so hence the nature of this polynomial is equal to f of x into P of x. For some f of x belongs to capital F of x. Okay, so this implies f of x is equal to 0. Why? Since if f of x is not equal to 0, then the degree of capital F of x into P of x. Okay, degree of this polynomial is greater than or equal to degree of P of x, which is equal to what? N. Okay, but here, what is the degree of this polynomial is x raised to n minus 1. Implies degree of f of
N minus
into
1.
P of x.
N minus 1.
Okay, which is greater than or equal to this one is n. They are equal to n. Okay, and so we cannot have we cannot have f of x into g of x is equal to a naught plus a1x up to so on a n minus 1 up into x raised to n minus 1. Okay, so this is the reason. Okay, so this implies a naught plus a1x plus a2x squared up to so on an minus 1 x raised to n minus 1 is equal to 0 into p of x is 0. Okay, hence this is the 0 polynomial. Okay, hence it implies all the coefficients of this polynomial must be 0. Just a naught, a1, a2 up to so on an minus 1 is a greater scalar 0 or 0 possible. Otherwise, not. Okay, so this implies a naught is equal to 0, a1 is equal to 0 up to so on an minus 1 is equal to 0. Okay, you put equation number star. So this implies that n vectors, which one? V plus 1, V plus x, V plus, okay, V plus x square up to so on V plus x raised to n minus 1 are linearly independent. Okay, these are the linearly independent over the field F. Okay, any doubt? Now we have to prove that these n
No,
vectors
sir.
generates E over F. To prove that V plus 1, okay, V plus X, V plus X square up to so on, V plus X raised to N minus 1 generates E is equal to, okay, capital F of X divided by V over the field F. Okay, now take any vector belongs to the field E. Let V plus F of X, okay, be any element of capital F of X divided by V. Okay, this F of X, okay, belongs to capital F of X. Okay, now we have to show that any element belongs to this field, we can express in the form of this and linearly independent vectors. Okay, so by division algorithm, by division algorithm, what we have? There exists Q of X and R of X. These are the two polynomials belongs to capital F of X such that F of X is equal to P of X into P of X into Q of X plus R of X. Okay, they divide F of X by P of X. What we get? The quotient one is Q of X and the remainder is R of X, where either degree of R of X is equal to 0 or degree of R of X is less than degree of P of X.
P of X.
Okay, now V is equal to F of X. V plus F of X with any element of that field E. Okay, so this we can write V plus what is F of X? P of X, okay, into Q of X plus R of X, okay, which is equal to V plus P of X into Q of X plus R of X. Sorry, V plus R of X. Okay, is it correct statement? Why? Give you the reason. H plus A plus B is equal to H plus A into H plus B. Is it correct? Plus. Okay, so this implies, but this polynomial belongs to what? Okay, V. And if A belongs to V, then V plus A is equal to what? V now. So this is V plus small f of x is equal to this one is V, and this one is V plus R of. Okay, so this is equal to now V plus V, 0 plus 0 element, 0 element is of E. So this one is E plus X, V plus R of X. So this is equal to V plus, what is the degree of R of X? Degree of R of X either 0 or less than degree of P of X. But what is the degree of P of X is N. Okay, hence the degree of R of X is less than N with what? The most at most degree of R of X is N minus 1. Okay, so V plus a naught plus a1x plus a2x square plus up to so on an minus 1 x raised to n minus 1. Is it correct? Okay, at most n minus 1
Yes,
असेल.
sir.
x square पण असेल, x cube पण असेल. ओके, त्यावेळेस जर काय असेल मग हा कोएफिशियंट वगैरे 0 असतील बाकीचे पैकी. Okay, at most n minus 1, the degree of r of x. This we can write v plus a naught plus v plus a1x plus v plus a2x square. Okay, up to so on. V plus an minus 1 x raised to n minus 1. Okay, what is the reason? By the definition of scalar, by the definition of vector addition in f of x divided by v. असंच केलं ना डिफाइन आपण. v plus a plus b जर असेल is equal to v plus a, okay, plus b plus b, okay, which is equal to v plus f of x. Now this one we can write in the form of this p plus 1 plus a1 into v plus x plus a2 into v plus x square plus up to so on an minus 1 v plus x raised to n minus 1. Okay, so look at here. So any element belongs to E, we can write in the form of v plus 1, v plus 2x, v plus x square up to v plus x raised to n minus 1. Where all the coefficients are belongs to field F. Okay, so this implies v plus 1, v plus x, v plus x square up to so on v plus x raised to n minus 1 generates f of x, that is E. Okay, f of x upon v, that is E. Okay, over the field F. Okay, thus it forms a basis of f of x divided by v over over f. Okay, thus the dimension of f of x divided by v over the field capital F is n. Okay, that is f of x of v, the dimension of f of x upon v over the field F is equal to what? That is, what is f of x upon v? Suppose this one is E. Okay, we assume that this one is E over F is what? Vector space. Okay, तुमचा कसा आहे?
N.
F. Okay, आपला isomorphic आहे under the mapping side F star. Okay, this one is suppose F star. And what is F star? तुमचा subset of E. That is, हा F कोणता झाला? हा F extension subfield of this one. Okay, फक्त the nature of element may be different, but property, all the properties of F and F star must same. Okay, equal असतात जे property satisfy करते. Okay, so here there exists the extension E of F such that the dimension of E over F is equal to F. Okay, any doubt up to here? Now, finally, we have
No,
to show
sir.
that P of x has a root in E. Okay, आपल्याला या P of x ला या E मध्ये हा एक root नाही exist असायला हवा. Okay, हे दाखवायचं आहे. Step number 2. Finally, we show that P of x has a root in E, which is equal to f of x divided by v. Okay. What is p of x? Let p of x be the polynomial. Okay, so that a naught plus a1 x plus a2 x square plus up to so on an x raised to n. Okay, p of x will be n, where all the coefficients belongs to f for all I. Okay, first let us make p of x. Let us make that p of x as a polynomial over e. Okay, आता हा p of x तुमचा polynomial कुठून आलेला आहे? p of x belongs to capital F of x. Okay, आपल्याला हा p of x काय करावा लागेल? p of x as a polynomial over e. Okay, over e वर करावा लागेल. मग काय करावं लागेल? e म्हणजे काय तुमचा? Capital F of x divided by v. Okay, पण या फील्ड मधला नेचर एलिमेंट नेचर कसं आहे? एलिमेंटचा नेचर v plus x. Okay, so instead of x we have to put v plus x. Okay, हा p of x तुमचा एलिमेंट कशात आहे? कशात आलेला आहे? कॅपिटल F of x. Okay, so any element of that capital F of x, the nature of element कशामध्ये असेल? तो x मध्ये असेल. ओके, आता पहिला हा पॉलिनॉमियल कशात नाही घ्यायचा आहे? ई मधून घ्यायचा. ओके, ई मध्ये रूट दाखवायचे ना पहिला. ओके, सो इन्स्टेड ऑफ एक्स पुट हियर v of x. बघा काय तुम्हाला. Okay, e is equal to what? F of x divided by p. Okay, first let us make that p of x as a polynomial over e. But what is e here? E is equal to capital F of x upon e. Okay, over e with the help of identification. We have made between f and f star. F star. Okay, so let us replace. Let us replace a naught by v plus a naught, a1 by v plus a1. Okay, so then p of x is equal to v plus a naught plus v plus a1 of x plus up to v plus an into x raised to n. Okay, now we show that v plus x belongs to e, satisfies p of x. Okay, आता ह्यात सगळे कोएफिशिएंट कशातून आले? फील्ड e मधून. Okay, v plus a naught, v plus a1, and we have to show that this v of x satisfies p of x. That means if we put instead of x v plus x, then we get 0 of e. Okay, here are some proof here. We show that this v plus x belongs to e, satisfies p of x. Okay, now what is p of v plus x? put instead of x v plus x. Okay, now this is the coefficient v plus a naught into this one v plus a naught into 1. Okay, plus v plus a1, this one is coefficient, into x means v plus x, plus up to so on v plus an. Okay, x is to लगाइए v plus x is to yeah bracket is to okay ये ना okay wait okay bracket is to okay positive the power 1 0 okay v plus x positive. So here the p of v plus x is equal to okay. Before going to the next step, look at this one. Now v plus x bracket square is equal to what? V plus x into v plus x. Okay, which is equal to v plus x square. Okay, similarly, v plus x bracket cube is equal to what we get? V plus x. Okay,
V
up to
plus
so on.
x cube.
V plus we get v plus x is to yeah. Okay, now put all the values in this above equation. So we get plus x is equal to v plus a naught plus v plus this is a1 and this one is v plus x plus v plus a2 into v plus x square up to so on. Okay, plus v plus an into v plus x raised to yeah. Okay, so we get p of v plus x is equal to this one v plus a naught plus v plus h plus a into h plus b. We get h plus ab. So here we get v plus a1x plus v plus a2x square up to so on v plus an x raised to n. By the definition of vector, addition of two vectors. Okay, so here we get v plus a naught plus a1x plus up to so on an x to n. Okay, what is this one? V plus p of x. Okay, ideal generated by p of x is equal to what? V. Okay, p of x. This implies p of x belongs to v. Okay, p of x belongs to v. Then v plus p of x is equal to what? V. Okay, this one is v. So this is p of v plus x is equal to what? V, which is equal to 0 element of field E. Okay, which is equal to capital F of x on V. Okay, thus V plus x satisfies. Okay, P of A is equal to 0 element all the time. So A satisfies that polynomial P of x. Similarly here, V of x satisfies P of x. Okay, so this implies V plus x is root of P of x. Okay, in the field E. Okay, is it correct? We have element, each element. Okay, so this implies V plus x. That is, this implies P of x has a root in E. Okay, So hence we prove that hmm, there is extension E of the field F such that the degree of E over F is n, and in which P of X has a root. Okay, any doubt up to here?
No, sir.
Okay, example घेतल्यानंतर अजून क्लिअर होईल व्यवस्थित. Wait a minute. Okay, आयसोमॉर्फिझमचा मिनिंग काय पाहायचं व्यवस्थित. आयसोमॉर्फिझम between F and F star. Okay, means the property. Okay, the property of the elements of F are continuous. Okay, to the elements of F star. Okay, याचा अर्थ काय, जे काही प्रॉपर्टी F सॅटिस्फाय करतोय तो सगळे F स्टार सॅटिस्फाय. ओके, फक्त नेचर दिसायला तो वेगळा जरी असेल तरी काय होतोय, तो प्रॉपर्टी सेम जो काही F असेल, ऍडिशन सबट्रॅक्शन, ओके, तो F स्टार प्रॉपर्टी. ओके, एनी डाउट? ओके, ओके, एक तर 14 मार्काला हा क्वेश्चन येईल कदाचित. ओके, 10 किंवा 14 मार्काला. हार्ड काहीच नाही. Okay, if P of X is an irreducible polynomial in capital F of X of degree n, which is greater than or equal to 1, okay, then there is an extension E of F such that degree of E over F is n, in which P of X has a root. Okay, now look at the example. एक example घेतल्यानंतर व्यवस्थित कळेल तुम्हाला. Example number 1. Let P of X is equal to x square plus x plus 1, okay, belongs to Z2 of X. Okay, तुमचा फील्ड काय ते Z2, फायनाइट फील्ड Z2 of X. हा, P of X हा इरेड्युसिबल आहे का पहा आधी Z2 वर. Okay, what is Z2? 0 and 1. Okay, what is P of 0? 1. What is P of 1? 1 plus 1 plus 1, 3. 3 is equivalent to 3 divided by 2 is equivalent to 1. Okay, in Z2, 3 is equivalent to 1. So here, we does not have a root in Z2. Okay, तुमच्या इथे Z2 मध्ये काय रूट नाहीये. आता काय होईल, वरच्या थेरमनुसार या Z2 चा असा एक एक्सटेन्शन तयार होईल. त्या एक्सटेन्शन मध्ये या P of X ला काय मिळेल, मला रूट मिळेल. ओके, answer. So here P of X is equal to x square plus x plus 1. Okay, and Z2 is equal to 0 and 1. And this P of X belongs to what? Z2 of X. All the coefficients look at here. 1, 1, 1, which is belongs to Z2. Okay, so here P of X is an irreducible over Z2 of, okay. Why? Because we don't have a root in Z2. ओके, एखाद्या पॉलिनॉमियल रूटला असेल तर आपण काय लिहू शकतो, लिनियर फॅक्टर मध्ये आपण लिहू शकतो. ओके, जर रूट असेल तर आपण लिनियर फॅक्टर मध्ये लिहू शकत नाही. दॅट्स व्हाय हियर द P of X then is reducible over Z2. Okay, now let alpha is a root of P of X. ओके, एक अल्फा आहे तुमचा रूट आहे कोणाचा पी ऑफ एक्स. ओके, जो Z2 मध्ये नाहीये पण तो कशाच्या बाबतीत असेल, एक्सटेन्शन मध्ये असेल, एक्सटेन्शन ऑफ या Z2. ओके, या Z2 चं काहीतरी एक्सटेन्शन केल्यानंतर काय असेल, हा अल्फा त्याच्यामध्ये असेल. लेट दिस वन इज अल्फा इज द रूट ऑफ पी ऑफ एक्स. सो adjoint this alpha to this Z2. Okay, now what is the nature of Z of alpha? A plus B alpha such that this A and B belongs to what? Z. Okay, so this is the nature of
Z.
Z of alpha. Okay, now Z2 मध्ये एलिमेंट किती आहे तिकडे आपल्याकडे? 0 and 1. Okay,
2.
okay, now put the value of A and B is 0 and 1. Okay, now put first A and B is 0 plus 0 alpha. Okay, now put B is equal to 1, 0 plus 1 alpha. Okay, now put A is equal to 1, B is equal. Okay, and put A and B is equal to 1, 1. 1 plus 1 alpha. Okay, now which is equal to 0. Okay, this one is 1, this one is alpha, and this one is 1 plus alpha. So this is the Z2 of alpha. Okay, what is the coordinate of this field? This set is 4. What is the coordinate of Z2 is
4.
2. So here the Z2 is contained in Z2
2.
of alpha. Is it correct? Okay, आता alpha चा तुमचा रूट आहे त्या
Yes,
field
sir.
मध्ये. आता we have to prove that this set is the field. जर हा जर तुमचा field झाला तर काय होईल? There is a extension of Z2 such that the P of X has a root in Z of alpha. This one is alpha. Okay. Now, to that Z2 of alpha is a field. Okay. From K table, you have to show that. What is the K table? काय याच्यामध्ये काय असणार ऑपरेशन काय तुमचा ऍडिशन मॉड्युलो अँड मल्टिप्लिकेशन मॉड्युलो. ओके, नाउ लुक ॲट हियर फ्रॉम K table. Okay. So, addition modulo 2. Okay, what are the elements? 0, 1, alpha, 1 plus alpha. 0, 1, alpha, and this one is 1 plus alpha. 0 plus 0, 0, 0 plus 1, 1 is alpha, 1 plus alpha. 0 plus 1, 1, 0 plus alpha, alpha. 0 plus 1 plus alpha is 1 plus alpha. Is it correct? 1 plus 1,
Yes, sir.
2. But what is addition model 2 is 0. This one is 1 plus
0.
alpha. Okay, 1 plus alpha plus 1. That is 2 plus alpha. But what is 2 plus alpha is alpha. So this one is alpha.
Alpha.
1 plus, this one is 1 plus alpha. Now alpha into alpha is alpha square. But what is alpha square? Look at here. P of x काय तुम्हाला दिलंय? X square plus x plus 1. Okay, then alpha is the root of this polynomial. Okay, so alpha satisfies this polynomial is what? Alpha square plus alpha plus 1 is equal to 0. The alpha is the root of it. Okay, so this implies alpha square is equal to minus 1 minus alpha. But what is minus 1 in Z2? Add करायचं काही 1. What is minus 1 into Z2? Plus 1. Okay, so what is alpha square is 1 plus alpha. So alpha plus alpha is alpha square, but alpha square is equivalent to 1 plus alpha. Okay, now 1 plus alpha आणि 2 कुठे येते अल्फा प्लस अल्फा 2 अल्फा. ओके, एक मिनिट. अल्फा प्लस अल्फा इज व्हॉट 2 अल्फा. व्हॉट इज इक्विव्हॅलेंट 2 इज इक्विव्हॅलेंट टू 0. कळते ना काय चालू आहे? 1
Yes, sir.
plus alpha and this one is alpha. Okay, that is 1 plus 2 alpha. 2 is equivalent to 0. So here we get only 1. Okay, similarly, here we get 1 plus alpha, 2 plus alpha. But 2 plus 2 is equal to 0. So 0 plus alpha is alpha. Okay. Now, alpha plus 1 plus alpha is 1 plus 2 alpha. That is 1. Okay, and this one is the 0. Hence, it is an abelian group. Look at here. abelian group आहे का? फील्ड होण्यासाठी आधी abelian group असायला हवा. ओके ओके. abelian group साठी काय व्हायला हवा? प्रत्येक कॉलम सेम हवा ना तुमचा. पहा, फर्स्ट रो फर्स्ट कॉलम सेम आहे, सेकंड रो सेकंड कॉलम सेम आहे, थर्ड रो थर्ड कॉलम and fourth row fourth column. Okay, hence Z2 of alpha with addition modulo 2 is what? Abelian group. Is it correct? Is it correct? Any doubts?
Yes, sir.
Okay. Now the multiplication modulo
No,
2.
sir.
Okay, field दाखवायचं दोन ऑपरेशन असते. 0 1 alpha 1 plus alpha 0 1 alpha. Now this one is 1 plus alpha. 0 into 0 0. Okay, 0 0. This one is 0. Okay, 0 0 0. 1 into 1 1. 1 into alpha alpha. 1 into 1 plus alpha 1 plus alpha. Alpha into 1 alpha alpha into alpha alpha square. But alpha square is equal to what? आता सांगितल्याप्रमाणे 1 plus alpha. Okay, alpha square is equal to what? काय तुमचा p of x काय? x square plus x plus 1. Okay, if alpha is root of p of x, then alpha satisfies this polynomial. That's why this is alpha square plus alpha plus 1, which is this implies alpha square is 0, which is equals, okay, minus 1 minus alpha is equal to minus 1 is equivalent to plus 1. So we get 1 plus alpha. Alpha square is equal to 1 plus alpha. Similarly, 1 plus alpha into alpha is 1 plus alpha square. So 1 plus alpha, 2 plus alpha. Okay. This one is 1 plus alpha. Okay, this one is 1. Okay.
Yes, sir.
1 plus alpha into 1 plus alpha. A square plus 2ab plus b square. Okay, 1 plus 2 alpha means 0 plus alpha म्हणजे काय? Alpha square काय? 1 plus alpha. Okay, this one is 2 plus alpha, which is equal to alpha. Inside 2 is equal to 0. That's why alpha is there. Okay, so hence from Cayley table we can say that this Z2 of alpha, which is equal to 0 1 alpha and 1 plus alpha, is finite extension of what? Z2.
Z2.
Finite extension of Z2 of x. Finite extension of it. Correct. Finite extension of Z2 also. Okay. In which roots are exist. Okay, any doubt?
No, sir.
Okay, second one is better. Because okay, second one is z2 of x divided by x square plus 1. Okay, so what is the set? This one p of x plus x square plus 1. Okay, such that this p of x is the element of z2 of, so z3 of x, z3, z3 of x. म्हणजे तुम्हाला कळलं का काय आतापर्यंत तुम्हाला फक्त झेडपी हा एकच फील्ड होता असं वाटायचं. ओके, प्राईम एलिमेंट्स ना, प्राईमचे काढण्यासाठी किती असेल, प्राईम असेल. मला तुम्हाला असा फील्ड जो मिळाला आहे. ओके, जसं ऑर्डर काय कंपोजिट नंबर पण आहे. ओके, म्हणजे आपल्याला असा फील्डही एक्झिस्ट तयार करू शकता येतो की नॉन प्राईम असेल, फायनाईट फील्ड. तो फील्ड आहे, फायनाईट फील्ड आहे. ओके, बट ऑर्डर ऑफ दॅट फील्ड इज नॉन प्राईम. Okay. Now look at it. Z3 of x divided by x square plus 1. Okay. P of x plus x square plus 1, such that P of x belongs to, this is Z3 of x. Now, if any doubt? If P of x divided
No, sir.
by x square plus 1. Okay. Assuming that P of x is greater than or equal to 2. Okay. So by division algorithm, we have that P of x is equal to x square plus 1 into Q of x plus R of x. Is it correct? Where this R of x belongs to what? Z3 of x. Okay. The degree of R of x has cell less than degree of x square plus 1 equal to 2.
X square
Okay,
plus 1.
so this implies the degree of R of x is equal to 0 or 1. Okay, say the degree of R of x is 1. Okay, and the nature of R of x is a plus bx, which belongs to z3 of x. Z3 degree element is 0, 1, 2. Okay, now put in the set. Which one? Z3 of x divided by x square plus 1, which is equal to x square plus 1 into q of x plus r of x. Okay, p of x value plus ideal generated by x square plus 1, such that this q of x into r of x and r of x belongs to z3 of x. Okay, so this implies हा सेट कशात जातो तुमचा ह्याच्यामध्ये जाईल आयडियल जनरेटेड बाय x square plus 1. So here we get r of x प्लस ओके चल हाँ आता कसं देईल हा एलिमेंट ह्याच्यामध्ये ओके कन्वर्ट सो वी गेट दिस वन इज r of x plus ideal divided by x square plus 1 okay such that the r of x belongs to z of x okay why because q of x in x square plus 1 belongs to z3 of x sorry not sure. This one ideal divided by x square plus 1 okay now plus m or a plus a is equal to m. This implies and implied a belongs to m. This is the reason. Okay. Now, possibility of r of x. R of x कैसे दोनों nature? R of x belongs to z3 of x. Okay. But what is z3? 0, 1, 2. What is r of x is equal to okay. A plus bx now. Look at here. R of x is a plus bx, where a and b belongs to what here? Z3. काय possibilities काय दिलेच्या बीच्या 0 plus 0x. Okay, a and b 0 0 a0 b1. Okay, a0 b2. Okay, a1 b1. Okay, a1 b0. a1 b2. Okay, now b2 a0 b2 आहे a2 b1x. Okay, a2 b2x. Is it correct? याच्याशिवाय कोणत्या पॉसिबिलिटी आहेत अजून? Okay.
Yes, sir.
So that is we set काही मजा 0 plus sorry 0 हा काही x 2x 1 plus x okay 1 खाली बोल दिया 2x from 1 1 plus x 1 plus 2x 2 2 plus x 2 plus 2x okay these are the possible values of r of x. They have possible values of r of x. Okay now cardinality of z3 of x. This implies the cardinality of z3 of x and ideal generated by x square plus 1 is किती एलिमेंट आहेत 1 2 3 4 5 6 7 8 9 ओके यासाठी काय म्हटलं आपण z3 of x divided by ideal generated by x square plus 1 हा कसा आहे सेट x plus x square plus 1 okay. R of x plus x square plus 1 okay असा दिसतो मला सेट such that R of x belongs to okay आणि R of x च्या पॉसिबिलिटी आहे ते 9 पॉसिबिलिटी okay मग याची ऑर्डर किती आहे ऑर्डर ऑफ दिस वन इज e ऑर्डर ऑफ e किती आले आहे ते किती आहे R of x च्या पॉसिबिलिटी किती आहे हा तर कॉमन असणार तुमचा ओके दिस वन इज 1 2 3 4 5 6 7 8 9 this one is 9 हा 9 कसा आलाय which is equal to 3 square हा जो काही असेल फील्डचा हा कुठे येईल हा खाली येईल ओके आणि या पॉलिनॉमियलची डिग्री जी काय असेल ते कुठे येईल वय. ओके, आता सपोज यासाठी काय असायला हवा, हा एक्स स्क्वेअर प्लस 1 हा झेड3 वर इररिड्युसिबल असायला हवा. ओके, suppose this is z5 of x divided by x square plus 3 असेल. ओके, सपोज हा इररिड्युसिबल आहे की नाही चेक करावं लागेल आधी. मग ह्याची कार्डिनल केस असेल, समजा हा इररिड्युसिबल पॉलिनॉमियल ऑफ डिग्री 2 आहे. z5 of x divided by ideal generated by p of x of degree, समजा ह्याची 3 डिग्री असेल, मग ह्याची कार्डिनल किती असेल, ऑर्डर 5 raised to 2. ओके,
5 cube.
कळते डायरेक्ट कसं करायचं. एनी डाउट अप टू हियर. Okay, so we
No, sir.
can form a field such that the order of that finite field is p raised to n. या फॉर्म मध्ये ह्या ज्याची ऑर्डर p raised to n असेल अशी आपण फील्ड तयार करू शकतो. ओके, एनी डाउट अप टू हियर. Okay.
No, sir.
Okay, so thank you for the attending the lecture. The remaining part we will see in the next lecture. Okay, so you can leave now. Thank you.